Today's Daily Dose of Math is about 4 volume formulas that I don't really need. They are the volume formulas for the cube, the rectangular prism, the cylinder, and the cone. I have all of these formulas written here, and none of them is very hard to use. But when you're in a geometry course and there is a list of formulas that you have to know, it's helpful if the list is a little shorter. So eliminating 4 formulas from the list I'm using is helpful. The formulas may be printed on your exam sheet, or you may be allowed a memory aid where you can write them in yourself, or you may have to memorize them. And in all cases, having fewer to deal with is better. Why don't I need these formulas? Well, let's go into that now. Let's start with the cube. That's the simplest example because the cube is a shape, three-dimensional shape that is 6 squares. Each face is a square, and the squares are all the same size. So when I give the side length of 4 here in a cube, I'm telling you all of the side lengths you need. The length, the width, and the height, they all have to be 4. The area of a square formula could be used to find the area of that bottom face of the cube. And it would be s squared, which in this case is 4 squared, which is 16 units squared. Then I have to think about what makes a cube. Imagine that square at the bottom. Imagine putting another square on top of it, and another, and keep on stacking up squares of the same size until the stack gets high enough so that it forms this cube. When we find the volume of a cube, what we're doing is we're taking the area of the square at the bottom and we're multiplying it by the height. The height is another 4. So s cubed is 4 cubed, which is 64. But I could have figured that out by finding the area of the square, getting the 16, and then multiplying it by the height, which I know. 4 times 16 is 64. This formula is the same thing as doing this formula and then multiplying by the height. And the reason that works is that that shape on the bottom, the two-dimensional shape, the square, if you imagine climbing up the three-dimensional shape, that shape on the bottom stays the same as you go up. And the same thing happens with the rectangular prism, so let's get into those. The area of the shape on the bottom of the rectangular prism is the area of a rectangle, which is length times width. In this case, I have 8 times 2. So I'm getting 16 units squared as my area of the rectangle on the bottom. When I multiply that by the height, which is the 4, I am doing the same thing that they did here, taking the length times the width, the 16, and multiplying it by the height, the 4. So 16 times 4 is 64 again. I have 64 units cubed as my volume of the rectangular prism. I didn't really need to use this formula. I just had to use this formula and then multiply it by the height 4, and I got the right answer. And it's working again, because that rectangular prism is like having a rectangle on the bottom and stacking up identical rectangles until you reach this height of 4. So the volume formula is just the area of the shape on the bottom times the height. And that's a concept of geometry that is easy to remember. With the cylinder, the shape at the bottom is a circle. And the area of a circle is pi r squared. We already have to know that. So if we use 3.14 as our pi, we have 3.14 times 2 squared, because the radius of this circle is 2, which is 3.14 times 4, which is 12.56 units squared. I have the area of the circle on the bottom. But that circle stays the same shape as you climb up the three-dimensional shape in a cylinder. So I can multiply by the height again. 12.56 times the height 4 is equal to 50.24 units cubed. I have my volume. I didn't actually have to do this formula. And when you look at the formulas, you can see it. There's the circle area formula. There's the same thing, but with an h. There's the square side squared formula. There's the same thing, but with another s, another side, which is the h. There's the area of a rectangle formula, and there's the same thing multiplied by an h. So this keeps working because the shape on the bottom stays the same as you climb up through the three-dimensional figure. But with the cone, that doesn't happen. The cone is a little bit of an exception, because the cone, that shape at the bottom, that circle, keeps on getting smaller as we climb up the cone. So that means we can't use the same trick. But we can still see something interesting when we look at this formula and realize the volume of a cone formula is the same as the volume of a cylinder formula, except for this divided by 3 part. The reason that's going to work so well in my examples is because this cylinder and this cone have the same radius and the same height. It is a fact in geometry that for a cone and cylinder that have the same height and radius, the volume of the cylinder will be exactly triple the volume of the cone. Therefore, the volume of the cone will be exactly 1/3 the volume of the cylinder, and that's reflected in the formula. Yet another formula I don't have to memorize, I don't really need. I can do my circle formula, multiply by the height, but because it's a cone, I have the extra step of dividing by 3, and I get my answer. I get the same answer that I would get if I used this formula. If you want to prove this to yourself, it's easy to do. What you do is you go to that sort of place where they have a big bottle of water, and you can get a paper cup to drink it from that's shaped like a cone. And then you take some paper and you make a cylinder out of paper, a cylinder cup, that has the same height and radius as that cone paper cup. And then you fill the cone cup with water and pour it into the cylinder. Fill the cone cup right up to the brim, pour it into the cylinder, and you will be pouring it exactly 3 times in order to completely fill the cylinder. Because this fact that the volume of the cylinder is exactly triple the volume of the cone always works so long as the radius and height are the same size. So I'm going to find the volume of this cone by taking the 50.24 volume of this cylinder and dividing it by 3. And it ends up being 16.75 units cubed. I didn't give units in these examples, so I use the word units as my unit. Remember to show that you know the unit is cubed for a volume. Therefore, the volume of the cylinder is 50.24 units cubed. The volume of the cube is 64 units cubed. And the volume of the rectangular prism is 64 units cubed. Using units as my unit is useful because it allows me to show that with area, my units are squared, with volume, my units are cubed. So this is the reason that we don't really need these 4 volume formulas. We know enough about more basic concepts of geometry so that we can figure out these volumes without needing the formulas. We know that these 3 shapes stay the same size as you climb up through the shape, and that means that the volume in all 3 cases is just going to be the area of the base times the height. And we know that so long as the radius and the height are the same in a cylinder and a cone, the volume of the cone is exactly 1/3 the volume of the cylinder. I'm able to find all of the correct volumes without using these 4 formulas. That means there are 4 less formulas on my list of formulas that I have to memorize or write on my memory aid or have printed on an exam for me. That is today's Daily Dose of Math. Please like, subscribe, and share.